Okay. Next, let's check the textbook. About the residual here. Okay, let me explain why the difference. Okay, please move to. There is a website. Called the Fate. P-H-E-T. Fate. Okay, I'm going to copy it to you. Okay. About the Fate, it's interactive simulations. Actually, it is very unusual because those simulations or the software created by University of Colorado Boulder, and the person, his name is Carl Wieman, Dr. Carl Wieman. How can I say that? He has been awarded the Nobel Prize in Physics, maybe the year of 2001, maybe 2001. Okay, and he donated some money, 250,000 US dollars to create this project. And wow, and I was the translator coordinator in Taiwan. Sure, we did the translation. And now I want to share this one. And please move to math and statistics. And I'm going to tell you, we can use this. Here, curve fitting, and graphing quadratics, and this one, and this one is also okay, and graphing slope intercept, and this one is okay. And now this is square regression. Okay. Okay, let me explain this first. And now, if I have data points like 1, 2, 3, 4, like this one, and now, if I move, the linear black line is generated automatically by the computer system. And now what I can do, just move those orange spots. For example, I move this one, I move this one, and you will see that when I move it, there are two values. There are two values. Generally speaking, the R-square value, the largest number is 1.0. And if I change the point, the spot or the point, you can see the blue column, the blue bar is changing, and the best fitting is to 1. For example, if I move this spot, and according to this calculation, the R square is 0.80. 0.80 is okay. It's okay. But if the spot scattering close to a line, for example, if I have some data about x, y, it looks like this, and I check the curve, the computer calculated the best fitting line as the black line. It looks like this, and we get x squared or chi-square 14.9. From this number, the smaller the better. From the R square value, the larger the better. Sure. In the future, how about please give a try of this one. 2 minutes. Again, please try curve fitting, and you can take a screenshot of this one and write out on your inside assignment, on class assignment. Okay, and when you move the round spots, for example, and according to this situation, the fitting curve, the formula y equals 0.64x plus 2.9, and the R square value 0.98. Chi-square, generally we don't think about the chi-square. Okay, if you move the spot on a different direction, for example, the trend is left side is higher, right side is lower, and you can see the coefficient of the x becomes negative. Y equals negative 0.71 minus 0.4. And sure, you can type something like this: quadratic or cubic. Yeah, when we select cubic, because 3 points can determine cubic to the power of 3. The cubic, and sure, it's 100% feet, 100% feet. And quadratic is power of 2, the square. You can move it, it's different. Yeah, sure, in the future, you can select the logarithm value of it, okay. If you want to do this, let me show you how to do this. Write down the notes. Select the range. Click it. No, okay. I think I don't have enough time. Sorry. I will skip this part. Okay. And next, you can try this. The least squares regression. And here, best fit line. Correlation coefficient. Okay, I have a spot, 2 spots, 3 spots. Okay, do you know what does it mean? Then we can change the xy. For example, if I increase the value of a, it means the slope. When the line is, the slope is 45 degrees, it means the slope is 1. When I increase that close to, this one, it looks okay. And now I can change the B. That will change the intersection. This moment, the B is 0. If I change the B, for example, to 1, to 2, when I move the knob, and the coefficient B becomes 1.68 or 2. And the line is very close to the red line. The intercept is here. 4.55. This location is on the y-axis, 4.55. And I can move the okay, get it? You can take a screenshot of this. Then you can move back to our textbook. What does it mean? Here is the residual, the length, the distance from the y distance from the point to the line, that is a residual. And take square. Take the square of it. It becomes this. Like this. The distance is residual, and now create a square. Like a square means to the power of 2. It also a shape like a rectangle, like a square root, like square, like this one. And here is the small. Try to find the square value as small as possible. Like this one. like this one, like this one. So this method is called find the equation of the regression line, find the regression of equation line. And for the example, the equation is y hat equals 35.0 plus 36.3x, like this one, like this one, like this one. Okay, and now let's move back to this side. How can we get the information like this? Let me tell you, we can do one more. Copy, paste, and there is an outlier. Can you get it? Outliers here, because from the x-axis, the reading very close to 0%, very close to 0%. This one is the exception, and delete. Click delete. And now I will change different color. Okay. Select this. Then insert chart. Yeah, see, very similar as the textbook. Like this one. Oh, like this one. Okay, and now we can change it. For example, here I click, and here is a key point because it's a very important step. Click here and move to the chart editor and click trend line. Click trend line. Then show R square. Show R square. Where is the equation? One minute, please. Okay, please practice this step. Again, you can select the range here and delete the outlier. Select all range and insert a trend line. Let me show you again. Click one spot. Okay, please practice this part. 2 minutes, 2 minutes. Okay, got it. Oh, finally. Okay, and if you want to show the x square, the r square is here, and show the equation, place here, click here, click chart editor, and click customize, and move to series, and here is a label, and please click use equation, and the equation is popping up like this. Y equals 33 times x plus minus 47.3, like this one. Okay, sure, we can compare it to our textbook. Okay. Oh, okay, I got it. Okay, now who can tell me why my calculation is different from the textbook? Because the textbook y hat equals 25.0 plus 26.3x, but my answer is very weird. Why? Who can tell me why? Who can tell me why? Oh, actually, I have the x and y. I can switch x and y. Then we are getting different answer. For example, let me show you here. X axis Okay, let me show again. Insert chart. Okay, I give up. Okay, so far any question? Okay, you can break this one. Okay, let's move to next one. And here is the residual, but maybe we don't need to calculate the residual because it's a little bit complicated. Okay, and this table, I may not give you the final exam question like this complicated because we just need to know. For example, I got the equation, I got the R-squared value. That's enough. That is enough. Okay. Okay, let's move to next. Yep. About the correlation, chapter 10.2 correlation. Correlation exists between two variables when the values of one variable are somehow associated with the other one. Okay, and now just a reminder, the correlation doesn't mean the reason and result. I have no idea whether how about you, the situation in your country, but in Taiwan it's a common mistake. Correlation doesn't mean cause and result. For example, according to the observation data, assume people like to eat sausage. And the people get the cancer, the possibility is increasing. Assume. Okay, but you don't know. You cannot say eat more sausage and it will be easier to get a cancer. No, it's not it's correlation, but not a cause and reason or results. Can you see it? Again, after they kind of survey, assume people in Taiwan, they are eating sausage and they get more cancer or more probability to get cancer. But you cannot say eat sausage must cause cancer. No, you cannot say that. You can say after the calculation analysis, you can see, wow, we found when people consume more sausage, the probability of getting cancer, have cancer, is increasing. You can say this, but you cannot say eating sausage will cause cancer. No, you cannot say this unless you have more evidence. Unless you have more evidence. But in Taiwan, the media always made a mistake like this. Okay, you understand? Okay, and now let's check this. Correlation. There are some correlation. For example, weak correlation, moderate correlation, and strong correlation used to describe strength of relationship between two variables. This one, moderate, the trend is from left down to upright. Strong correlation, perfect positive correlation. And here, when there is a trend line from top left to down right, that is negative correlation. No correlation, nonlinear correlation, it can be a quadratic correlation. And the term linear correlation coefficient is a number of this to describe a strength of linear correlation between two variables, and called the Pearson correlation coefficient after Carl Pearson, who developed it, like this one. And here we don't need to know the details about this one. Interpretation of correlation coefficient. R is always between -1 and 1. And the R, when the R is -1, it means a perfect negative linear correlation. And when the R is 1, it means perfect positive correlation. The closer R is to the 1 or -1, the stronger the correlation. The closer R is to 0, weaker the correlation. Okay, again, R from -1 to +1, it means the highly correlation or low correlation. 0 is the lowest one. You may say, wow, -5, how about -5? No, it's a negative correlation, not negative correlated. Careful, when R equals 0, do not mean the no correlation. It just means no linear correlation. Maybe you can transfer the value into logarithm. You can get a good correlation. They might have very strong curve pattern. Here, how strong is the positive relation between the alcohol content and number of calories in a 12-ounce beer? To determine if there is a positive linear correlation, a random sample was taken of beer alcohol content and calories for several different beers, like this one. The data are tabled here. And state the random variable, like this one. And then, after the calculation, we got R, not R squared, the R value 0.9, and this is close to 1. This is close to 1. Causation, and please, how can you get 0.915 like this one? When we move it, we got R squared 0.834. How can you get this? Click here and get the value. Chart, okay. Axis, author content, series. Here, trace line and check the R square. Check the R square, and we got the R square is 0.834, and the square root of it is 0.91, like this one. Like this one. Okay, and now I hope you can finish this assignment, finish this one, and have the equation, have the R square value. You may say, wow, it's different, how can you get it? Yeah, you can use this, the calculator. The calculator, square root of 0.834, we got this, the same as this one, the same as this one. Is it okay for everyone? Okay, have 10-minute break, then I will see you back. Okay.